So here we are given that this man is driving the car at 40 miles per hour, but the speed limit is 25 miles per hour. So at the instant the speeder passes the police car, the police starts chasing him with an acceleration of 4.51 meter per second squared. Now we have to calculate when the police will catch the speeder, and there are a couple of more parts that we need to solve in this question, and I'm sure that after watching this video you'll be able to give this answer comfortably. We'll discuss this question at the end of the video. Welcome to STEM Professionals. In this video we'll discuss the applications of equations of motion. So let's start with the video. In the last couple of videos, we derived equations of motion, and in this video, we'll take a couple of real-world problems that further illustrate the use of constant acceleration equations of motion. But before that, let me summarize all the equations that we derived. The first equation that we derived was V is equals to V naught plus AT. This was the first equation. Here V is the velocity, basically the final velocity. V naught is the initial velocity, A is the acceleration, and T is time. Now the second equation that we derived was X is equals to X naught plus 1 over 2 V naught plus V times T. This is the second equation that we derived. Here X is the final position, X naught is the initial position, V naught is the, as explained earlier, initial velocity, V is the final velocity, and T is time. And while deriving this equation, we studied one more equation, which was average velocity is equals to 1 over 2 times V naught plus V. Now the third equation that we derived was X is equals to X naught plus V naught T plus 1 over 2 A times T square. This was the third equation, and the final equation was V square is equals to V naught square plus 2 times A times X minus X naught, and we have written this X minus X naught as delta X. So this was the fourth and the final equation. Now one important note is that all these equations are valid only for constant acceleration. If the body is moving or the particle is moving at constant acceleration, then only we can use these equations, otherwise not. Now let's discuss the first real world problem. So this is the first real world problem that we're going to discuss, and here we are given that the ranger is driving at a speed of 11.4 meter per second, and suddenly he sees a deer. So immediately he applies brakes and slows down the car with an acceleration of 3.80 meter per second squared. So this is the direction of velocity, and the acceleration would be opposite. The direction would be opposite to that of velocity because the speed is decreasing. So this must be the direction of acceleration, and this is the direction of velocity. Now there are two parts in the equation that we need to solve. We're going to solve the A part first, and in the A part they are saying that if the deer is 20 meter from the ranger's vehicle when the brakes are applied, then we have to tell how close the ranger come to hitting the deer. So basically we have to tell that what would be the distance between the car and the deer. So let us assume that the velocity of the car becomes 0 at this position, and let me define the coordinate system also. So this is the positive x-axis, and this is the initial position x naught, and this is the final position x. And now we have to calculate this distance we have to calculate. Now for that we're going to use the equations of motion that we derived earlier. So the equation we can use is V square is equals to V naught square plus 2 times A times delta X. Now here the initial velocity we are given to be 11.4, Now final velocity, we are assuming that at this position it is becoming 0. So this term should be 0, and from here we can write that delta x is equals to minus v naught square divided by 2a. Now we can put the values, acceleration and velocity we know. So from here delta x, this would be equals to v naught square is 11.4. So this is 11.4 meter per second, and it's squared, divide by 2 times. Now acceleration is 3.8. So this would be 3.80. So that would be equals to 17.1 meter. So this distance delta x, it comes out to be as 17.1 meter, but we have to calculate this distance. So this distance would be this total distance, which is 20 meter, minus this delta x, which is 17.1 meter. So that would be equals to 2.9 meter. So this would be the answer for the A part. Now we can solve the B part. Now in the B part, they are asking that how much time is needed for Ranger vehicles to stop. So the time taken to stop the vehicle, this is what we have to calculate. So for that, again we can use the equation of motion, which is v is equals to v naught plus at. Now from here we can write that since this velocity is 0, the final velocity is 0, we can equate it to 0, and from here this t would be equals to v naught divided by a, and there should be a negative sign. So this is the expression for time that we have obtained. Now the initial velocity that we are given is 11.4 meter, 11.4 meter per second, sorry, divide by, now acceleration we have 3.80 meter per second squared, but since the direction is opposite, so we have to take a negative sign here. So negative 3.80 meter per second squared. So from here time t equals to 3 seconds. So in 3 seconds the Ranger will stop the car. So this would be the answer for the B part. Now from this question we observed couple of observations. The first observation is that this delta x is directly proportional to v naught square, because this acceleration is constant. So this delta x is directly proportional to v naught square. That is, if the initial velocity is increased by a factor of 2, then this delta x, the stopping distance, will increase by a factor of 4, because this is proportional to square. So if this is increased by 2 times, this would increase by 4 times. Now another observation that we have observed is this one, that t is v naught divided by a. Now this time t is directly proportional to v naught. Now if the initial velocity is increased by a factor of 2, then the time taken to stop the car will also increase by a factor of 2. You can take one example, like this is 11.4. Now if it becomes 22.8 meter per second, then the time taken to stop the car would be double of this number, that is 6 seconds. And similarly here also, but here this would become 4 times. Now based on these observation, I'll be giving one conceptual question to you, and the question is that if the Ranger applies the brake for a distance of delta x over 2, let me show it on the figure, that if the Ranger applies the brake for a distance this much, that is delta x over 2, now what would be the speed at this position? This is what you have to tell. And the options are, A part is it equals to the half of initial velocity? Is it greater than the half of initial velocity, or it is less than v naught by 2? Any of one option is correct, and you have to give the answer in the comment box below. Now we'll get back to the question that I discussed in the starting of the video. So this was the question, and here Speeder is running the car at a velocity of 40 miles per hour, which is about 17.9 meter per second. Now since the Speeder crosses the speed limit, the police car accelerates to catch the Speeder. Now this is the picture, shows the instant when the speeder car just passes the police car at rest. So let me first define the coordinate system. So this is our coordinate system, and this is direction. It's a positive x axis and basically the direction of motion. Now here this is the initial position of both the car. That means it's x0, we have 0. It's an origin, and time at this is time also equals to 0. Now the speeder and the police car are at the origin and time is 0. Now the initial velocity for speeder is 40 miles per hour, which is 17.9 meter per second. So there is the initial speed for the speeder, which is 17.9 meter per second. Now since the police starts at rest, so its initial velocity for the police car, it will be 0, and the acceleration for police car is 4.51 meter per second, and the acceleration for the speeder car is 0 because it is moving at constant velocity. Now there are three parts in the question. In the first part, we have to find how much time does it take for a police car to catch the speeder. Now let's suppose that at this position the police car catches the speeder's car. So this would be the final position for the police car. This is, let it be, this is xf, the final position, and the final position for the speeder car would be this xf. Now if you see, the distance traveled by the police car and the speeder car is same, so let this distance be xs, distance traveled by the speeder car up to this position, and let this distance be xp, and xs is equals to xp. From this figure we can conclude that this is equals to this one. Now but what we have to calculate, we have to calculate the time that the police car take to catch the speeder. So we can do one thing, we can equate the distance traveled by the speeder car and the police car to find the time. So we're going to use the equations of motion. So I'm writing here, this is for police car, and here I'm writing for speeder. Now we studied one equation, which is x is equals to x0 plus v0 t plus half at square. So we're going to apply this equation for this one and for the second case. So for police, we can write that xp will be equals to x0. Now initial position we have 0 for police, x0 is 0, so we can put it as 0, plus now initial velocity is also 0, so 0 plus half at square as it is. Now for speedo, xs is equals to, now initial position is 0, initial velocity we have, so it is v0 t. Now there is no acceleration for the speedo because it is moving at constant speed, 17.9 meter per second, so its acceleration would be 0, so plus 0. Now since both of these distances are equal, so we can equate these two things. So we can write that half at square is equals to v0 t, and from here this t will cancel like this, and from here we'll get the expression for time, t is equals to 2 v0 divided by a. Now we have all the values, we can plug it here to find the time. So v0 we have 17.9, so this is 2 times 17.9 meter per second divided by the acceleration. So acceleration we have 4.51 meter per second. This acceleration is for police, this is basically AP here, so this is 4.51 meter per second squared. Now from here we can easily find out the value of t, and the value of t comes out to be as 7.94 second. So this would be the answer for the A part. Now next in the B part we have to find that how far have the two cars traveled in this time. Now the distance traveled by two car is same. Xs is equals to xp. So we can do one thing. We can either put in this equation or in this equation. We'll get the same answer. So let us put in this equation. So xp will be equals to, this is the b part. Now this is 1 over 2. Acceleration for police car is 4.51. It's basically meter per second squared, not meter per second. So 4.51 meter per second squared times t square. So time we have calculated to be 7.94 and it squared. So this would be equals to 142 meter. So the distance traveled by both the car will be 142 meter. So this would be the answer for the B part. Now next we can solve the C part, where they are asking that what is the velocity of the car when it catches the speeder. So for that we can use one more equation of motion, which is V is equals to V naught plus AT. Now this is for police. I'm applying this equation for police car. Now the initial velocity for police car was 0, so this is 0 plus acceleration was 4.51 meter per second squared, and the time when it catches the speeder was 7.94 second from the initial time. So this is 7.94 second, and from here this velocity comes out to be as 35.8 meter per second. So this is the answer for part C. That is, when the police catches up the speeder, they were running at velocities 35.8 meter per second. Now if you observe carefully, when the police catches up the speeder, the velocity of the police car is exactly twice the velocity of speeder. If you see here, the velocity for speeder was 17.9, and when police catches up its velocity is just the double, that is 35.8 meter per second. So is this a coincidence? Pause the video and try to think. Now the answer is no, it is not a coincidence. Let me explain. Now when the police car catches up the speeder, both the car have traveled the same distance, xs, and this xp is same, and time taken to travel this much of distance is also same. That is, we can conclude that the average velocity for the speeder and the average velocity of the police car is same. Now since the speeder was running at constant velocity, so the average velocity for speeder would be equals to its initial velocity, that we can take it to be Vs, which was 17.9 meter per second. Now the police car accelerates, and for constant acceleration the average velocity is given by half of initial velocity plus the final velocity. Now initial velocity is 0 for this police, so this would be 0. So its average velocity would be equals to 1 over 2 the final velocity, which we can take to be V. Now since the average velocity for both the car is equal, so we can equate these two things. So we can write that Vs is equals to 1 over 2V, and from here we can write that the final velocity for the police would be 2 times the velocity of the speeder. Thus it was not a coincidence. Now there is one practice question for you. You have to repeat the above problem, but for this case the acceleration of the police car is 3.25 meter per second squared. Rest everything is same. So this is the practice question. Now this is all with this video, and in the next video we'll discuss about freely falling bodies. Goodbye.